Hi, my name is Julia and this is Space Daily News Channel. NASA's James Webb Space Telescope captured its first images and spectra of Mars on September 5. The telescope provides a unique perspective with its infrared sensitivity on our neighboring planet, complementing data being collected by orbiters, rovers, and other telescopes. Webb's unique observation post nearly 1,000,000 miles away at the Sun-Earth Lagrange point 2 provides a view of Mars' observable disk, the portion of the sunlit side that is facing the telescope. As a result, Webb can capture images and spectra with the spectral resolution needed to study short-term phenomena like dust storms, weather patterns, seasonal changes, and processes that can occur at different times of Martian day. Because it's so close, the red planet is one of the brightest objects in the night sky in terms of both visible light and the infrared light. This poses spectral challenges to the observatory, which was built to detect the extremely faint light of the most distant galaxies in the universe. Webb's instruments are so sensitive that without special observant techniques, the bright infrared light from Mars is blinding. Astronomers adjusted for Mars' extreme brightness by using very short exposures, measuring only some of the light that hit the detectors, and applying special data analysis techniques. Webb's first images of Mars, captured by the near-infrared camera, show a region of the planet's eastern hemisphere at two different wavelengths of infrared light. This image shows a surface reference map from NASA on the left and two Webb's near-infrared images on the right. The near-infrared camera shot a wavelength image is dominated by reflected sunlight and thus reveals surface details similar to those apparent in visible light images. The rings of the Huygens crater, the dark volcanic rock of Syrtis Major, and brightening in the Hellas Basin are all apparent in this image. The near-infrared camera longer wavelength image shows thermal emission, light given off by the planet as it loses heat. The brightest region on the planet is where the Sun is nearly overhead. The brightness decreases toward the polar regions, which receive less sunlight, and less sunlight is emitted from the cooler northern hemisphere, which is experiencing winter at this time of year. NASA's team also released Webb's first near-infrared spectrum of Mars, demonstrating Webb's power to study the red planet with spectroscopy. Preliminary analysis of the spectrum shows a rich set of spectral features that contain information about dust, icy clouds, and the composition of the atmosphere. The spectral signatures of water, carbon dioxide, and carbon monoxide are easily detected with Webb. In the future, the Mars team will be using this imaging and spectroscopic data to explore regional differences across the planet and to search for trace gases in the atmosphere of Mars. This was Space Daily News. Subscribe to the channel.